guys, today we are going to solve one JEE mains circular motion question. So let me start to solve, guys. The question is, a particle begins to move with a tangential acceleration of constant magnitude 0.6 meter per second square in a circular path. If it slips when its total acceleration becomes 1 meter per second square, find the angle through which it would have turned before it starts to slip. And guys, this question was asked in JEE mains 2021 past year question. Okay, so guys, first tell me what is the formula for total acceleration? I mean net acceleration. The formula for net acceleration in a circular motion is nothing but I will represent the net acceleration as A net. This is net acceleration. Net acceleration is same as total acceleration. So formula is root of AT square plus AC square. This is the formula for net acceleration in a circular motion, where your AT is tangential acceleration which acts along the tangent of the circular motion, and AC is the centripetal acceleration that acts towards center. Okay, you know radial acceleration now. So centripetal acceleration is one of the type of radial acceleration. I hope you know that. Okay, so from radial acceleration only we derive the centripetal acceleration. So this is the formula for net acceleration, and we know this already because a net acceleration is the vector sum of tangential acceleration and centripetal acceleration. Because tangential acceleration will be like this, centripetal acceleration will be like this. This is how both these acceleration looks, and total acceleration will lie like this in between the resolution. Okay, resolution means addition, like that you can say, and that's how this formula is derived. So keep this formula one side. Keep this formula one side. Now tell me one thing, what is the third kinematic equation of circular motion? What is the third kinematic equation of circular motion? The third kinematic equation of circular motion is nothing but omega square is equal to omega naught square plus 2 alpha theta. This is the third kinematic equation of circular motion. Your third kinematic equation in motion in plane is what? Motion in plane, or we can say it as kinematic itself. So in kinematics, we say it as v square is equal to u square plus 2as. Instead of that, this is the third kinematic equation of circular motion, where the variable just changed. Like your velocity changed to angular velocity, acceleration changed to angular acceleration, displacement changed to angular displacement. So that's how the angular variable changed. So the kinematic variable changed to circular variables. That's how this equation looks, where your omega is angular velocity, omega naught is the initial angular velocity, alpha is the angular acceleration, and theta is the angular position. Angular displacement is delta theta. Change in angular position is only angular displacement. Your theta is angular position, delta theta is only angular displacement. I hope you know these things. Now guys, tell me one thing. In this question, your omega naught is 0 now. From the question itself, I will say that your initial angular velocity omega naught is 0 because they clearly states that a particle begins to move. A particle begins to move. Try to read out the question fully. When you read out, you can find that at the instant of start, at the instant of the particle starting, the acceleration, the angular velocity will be 0 now. Even you learn this in kinematics. At the instant when it starts, the initial angular velocity will be 0, and that's why I am saying your omega naught will be 0. Initial angular velocity will be 0 for this particular circular motion in this question, because they are saying a particle begins to move. At the instant it start to move, the initial angular velocity will be 0. Basic common sense. So when your omega naught is 0, this same equation can be written as omega square is equal to 2 alpha theta, because we know that your omega naught is 0 from this question. Now guys, after this, from this equation only, I am going to do some changes in order to find the angle through which it have turned before it starts to slip. Basically, we should solve for this theta, because this theta is what they are asking in the question. This theta is what they are asking in the question. Because read the question carefully. This theta is something they are asking in the question. Okay. Now, in this particular equation, I am going to multiply your radius r on both sides of the equation. I am going to multiply your radius constant r on the both sides of the equation. When I multiply, I will get the same equation as r into omega square will be equal to 2 into r into alpha into theta. Correct na? This is what you will get when you multiply your radius r. The constant radius r on both sides of the equation. And this radius r is nothing but the radius for this circular motion. For this circular path given in this question. For this question only I am introducing new variables. I hope you understand that. This radius r that I am multiplying on both sides of the equation is the radius of this particular circular path, or by circular motion in this question. Okay. So I just multiply this radius r. This radius is the radius for the circular motion given in this question. Okay. So what is r into omega square? Omega square into r. Omega square into r is nothing but, what is omega square into r? It's a basic concept. That is your centripetal acceleration. Correct now? Omega square into r is your centripetal acceleration, because centripetal acceleration is the acceleration towards center. So the magnitude of centripetal acceleration is omega square into r, or we can say it as v square by r. You will get v square by r when you put the omega as v by r. That's one of the relationship. So omega square into r is centripetal acceleration. You should know that already. In order to get the centripetal acceleration only, I multiply your radius r. Okay. So this will be equal to 2 into r alpha. What is r alpha, guys? Tell me. Your r alpha is nothing but at. Your r alpha is nothing but at. At means tangential acceleration into theta. And this theta is something that we are supposed to find. So basically you know omega square into r is a centripetal acceleration, but you have doubt how r alpha will be tangential acceleration. So I will derive you that. So basically guys, what is the standard formula for at? That means tangential acceleration. The standard formula for tangential acceleration d by dt, that is nothing but your rate of change of speed. Guys, there is no rate of change of velocity. Never ever do that mistake. Many people commit this mistake. It is rate of change of speed, not rate of change of velocity. If you have v, it does not mean that it is rate of change of velocity. Guys, don't do this mistake. If you did not hear it carefully, then of course you will regret. Okay. So this v is not velocity, it is speed. Again and again I am saying. So your tangential acceleration is rate of change of speed, not velocity. Never ever do that mistake. So now I can write this v as, listen, omega into r. Correct now? I can write this v as omega into r because that's a relationship. That's a relationship that you guys know. So let me represent this radius r as constant. Okay, that's good now, so that you can understand this. So this velocity can be this, that means this v, not velocity, speed. Okay, so this speed can be represented as omega into r, linear velocity. I hope you know that. So v I can represent as omega into r because that's a type of relationship, and from this only we derive that your omega is equal to v by r. V is equal to omega, that's a relationship, guys. You should know that, because in circular motion it's a very important part. So your v is omega into r, that's a relationship. Now from this, I'm going to take this radius r outside because it is a constant now. I'm going to take this radius r outside this differential coefficient. When I take, I will get it as d omega by dt. Correct now? When I take, this is what you will get. I hope you know that. Just I took your radius constant r outside the differential coefficient. That is d by dt is coefficient. You know these things. Okay. So I just took your radius or constant outside the differential coefficient, then I will be left with r into d omega by t. So I can write it as r into d omega d. D omega by dt what? D omega by dt is nothing but alpha, angular acceleration, because your angular acceleration is defined as rate of change of angular velocity. You know that na? D omega by dt is only alpha, as alpha is rate of change of angular velocity, and that is why I am saying your r alpha will be at. So finally I will say that this is your at. Okay. Now I hope you understand. So guys, I derived, guys. This is a question I can't explain, but anyway I did, so no problem. So at is equal to r alpha. Please remember that. In H.C. Verma and some other books also you have. Anyway I did it. Okay, no problem. Now this is the relationship that we got now. Now guys, in the question itself they gave the value of tangential acceleration. What they gave? 0.6 meter per second square. So the value of tangential acceleration is at is equal to 0.6 meter per second square. The question itself they gave. See, a particle begins to move with tangential acceleration of constant magnitude 0.6 meter per second square. That is, your tangential acceleration is 0.6 meter per second square, and that is what they are saying in the question. Now, I also found the relationship that centrifugal acceleration is equal to 280 into theta. Already we know the value of AT, that is 0.6. When I put the value, I'll get your AC as 2 into 80 into theta. What is AT? 0.6. So 2 into 0.6 is what? 1.2. So 1.2 into theta, and that will be the value of centripetal acceleration. And that is why I multiply your radius on both sides. After that, I wrote your R alpha as AT. So that it will be very simple for you people. Because we already know the value of tangential acceleration. So I just evaluated the value of AT in this particular equation. So I will get your centripetal accelerations 2 into 80. 80 is given 0.6 meter per second square. That is tangential acceleration. So 2 into 0.6 is 1.2 into theta. So now I will rub this. Guys, this relationship is very important. Now after this, it's gonna be very simple, guys. In the question they are given, if it slips and its total acceleration become 1 meter per second square. Total acceleration and net acceleration both are same. You know that, okay? So your net acceleration and total acceleration is same. So I can write it this particular. Now let us come into this equation. Now I'm going on to this equation. So your net acceleration is what? Is given as 1 meter per second because meter per second square. So your total acceleration and net acceleration both are same. I already told that. So total acceleration is 1 meter per second square. That is net acceleration is 1 meter per second square. So 1 is equal to root of AT square. What is AT square? AT 0.6. So 0.6 square will be what? 0.36. Then plus of AC square. What is AC square? 1.2 into theta whole square. That is your AC square because your AC is 1.2 into theta. And now we are supposed to find the value of theta. If we found the value of theta, then we done with the question. Okay? Okay, so that's what we are supposed to do. We are supposed to find the value of theta. So net acceleration 1 is equal to root of AT square, that is 0.6 square, that is 0.36 plus of AC square, that is 1.2 theta whole square. Now it's gonna be very simple. In this equation, square on both sides. When you square on both sides, I will get 1 square. 1 square will be 1 only. When you square on RHS, you will get it at 0.36 plus 1.2 into theta whole square. Now we are supposed to solve this equation. So 1 minus 0.36 will be equal to 1.2 theta square. Now after this, what is 1 minus 0.36? I think it is 0.64, no? 0.64 will be equal to 1.2 theta whole square. Now after this, take square root on both sides of the equation. So square root of 0.64 is 0.8. And when you take square root on this RHS, you will get 0.2 theta. Sorry, 1.2 theta. Correct, no? This is the equation I finally arrived. So just I took square root on both sides of this particular equation. So 0.64 square root is 0.8. 1.2 theta whole square root is 1.2 theta. Very simple. As I am having square root, I can directly write the base. That is 1.2 theta. Just took square root on both sides. Now after this, we are supposed to find the value of theta, and that is something asking in the question. So 0.8 is equal to 1.2 theta, means the theta will be 0.8 by 1.2. 0.8 by 1.2 is 2 by 3. 2 by 3 degree, no radians. So your theta is equal to 2 by 3 radians. So that's the answer for the question. Beautiful question, guys. I liked it to solve. So theta is equal to 2 by 3 radians. It is not degree, guys, because in when you come to circular motion, for angular displacement, the SI unit is radian. The unit is radian, and for the angular velocity, the unit is radian per second. For angular action, the unit is radian per second square. For only tangent acceleration, it is meter per second square. Because tangent acceleration is the acceleration along tangent. Tangent is rectilinear, na? That is why it is It is meter per second square. But in circular variables, you have radians. In terms of radians only, the units will be there. So theta is equal to 2 by 3 radians. So what is 2 by 3? I think 0.66. You don't need to represent. Just 2 by 3 radians is the answer for the question. It's a good question, guys. That's all, guys. I hope you guys will enjoy this question. Thank you. Make education simple.